these a little bit more difficult topics. So we get to go over them more times during the semester, and hopefully we'll get over it by the end of the semester. All right, so that's the idea. That's the idea. So alpha 5 is one of those. Alpha 5 is one of those. Okay, not only they're kind of difficult, but they're also a little bit tricky. I give you a little quiz about this. Okay, I give you a quiz. That quiz was out yesterday. It's about the understanding this idea, this, you know, alpha 5. Alpha 5. So you guys are looking at alpha 5? Over here? Does everybody follow me? Do you guys see alpha 5 right here? Yes? We worked on it last time, didn't we? We worked on it a little bit, I think, right? We worked on it a little bit last time. We did the graph. Okay. This is one of those places that it seems to be easy, but people make a lot of mistakes. Okay. All the students I have taught so far, okay, have some trouble with the absolute value. Okay, after this, we're going to work on absolute value equation and so on and so forth. Okay, so we did the graph. Okay, so we did the graph. That's the absolute value function. Okay, I'm going to bring it to the top. I'm going to bring it to the top. Okay. And then with that being as our reminder, okay, with that as our reminder, we're going to start alpha 5. Alpha 5. Alpha 5 is certainly is not new. Okay. We says understanding this whole thing. Okay, so I'm going to copy and paste. I'm going to copy and paste, and then we're going to transition to another window, right? To another share. Okay. So understanding. I'm going to stop share. I'm going to start another share with you. Okay, you look at alpha 5 on your notes, and I'm going to put on this screen. The first part we want to understand is the square root of x squared is equals to absolute value of x. We talked about that, didn't we? Did we talk about that last time? Okay. And we understand why this is a mistake, right? The square root of x squared equals to x. That is a mistake. But this is a very popular mistake. This is a very popular mistake. But once again, just because it's popular doesn't mean it's correct, right? Just because it's popular doesn't mean it's correct. In this case, it is popular, but it's incorrect. Okay, it's a terrible mistake. Now, the next piece of this is, okay, the first piece is that the root of x squared equals to absolute value of x. Is there any question? Any questions? Let me see. Did I do the recording? Okay, I did the recording. Okay. Any questions on these? Everybody? Any questions? Any question about this?
No questions, Professor.
Good, good, good. Okay, are you sure?
Well, I'm sure.
Okay, you're sure. Very good. Okay, so let's look at the next piece. Okay. The next piece says, this is a little hard to understand. for a lot of our students. Okay, this one has a 2 branch. Okay, as branches. One is X. Okay, if X is greater than equals to 0, and the other piece is negative X if X is less than 0. What does this mean? What does this mean? Okay, so we're going to work on this piece. This. Okay, so I'm going to explain to you what this is. Okay, I'm going to explain to you what it is. Even though there's some explanation from in the notes, okay, which I excerpt from. I took the excerpt from from a textbook, which is a calculus textbook, but I'm going to explain to you on this. Okay, so first we're going to put it away. Okay, first we put this away. Okay, we put this away. I want to show you how mathematics make things simple, make shorthand notation. How mathematics makes shorthand notation. Okay, and how we should read it. Okay, the first one is that we all know that the absolute value. Okay, I'm going to give you a couple of numbers, right? Give me the answer, right? Give me the answer, please. And give me the answer, please. Could you give me these answers? One more.
The first one is 2.
Very good.
3. 5. 0. 7.
Perfect. Perfect answer. Perfect answers. Okay. From these perfect answers, we want to observe some patterns. We want to observe some patterns. Okay. So how would you observe patterns? What I would do is I'm going to say, okay, we have 3 categories of numbers in this case, right? 3 categories. 3 categories. Okay. So I'm going to make 3 columns. Okay. One case is X is greater, the number is a positive number. Positive number, positive input. Okay. So we're going to consider the fact that we look at the function's perspective, right? The perspective is X is, the f of X. Okay, so I'm gonna go from the function's perspective, and this is absolute value. Just be patient with me, okay? And so I'm going to just produce the output. The output is absolute value. Okay, and here's the input. And of course, here's the output. Okay, here's the output. So in terms of input, okay, so if the input is a positive, right? If the positive input or if it's a 0 as input, and the next case, of course, is a negative number as input, right? Negative, positive number input, positive number input. I want to have this color. Okay, positive number input, negative number input. Okay, does everybody follow me? So among all of these examples, okay, so which one fit into positive number input? The first one, right? The second, the third one. Which one fit in the zero input? Zero. How about the negative numbers? Negative numbers. So we have these examples. And we start to observe each category. We start to observe each category. So what have we found? What have we discovered when we observe these patterns? Oh, have we observed any patterns? And we notice, so I'm going to give you a start, okay? The absolute value of 0 is the same as 0, right? The absolute value of 0 is the same as 0. Maybe I think my table is a little bit, because we're gonna run out of space. Okay, so I'm gonna make a different table. So I want you guys to observe the pattern. Okay, so what have you discovered? Positive input. Okay, 0 as input. Okay, I'm just gonna turn the table. So what have you observed about a positive number as input?
It came out the same.
It came out the same. The input is always the same as output, right? How about 0 as input?
It's the same number as 0.
That's right, the absolute value. So we have the example right here, the same as 0, right? So what is the summary here? What is the summary you would put on the last column? So let me put it on this row here. Okay, so we're gonna summarize. We're gonna summarize. So what have you seen for negative number as input? For 0, do you agree with this summary I put there? Do you agree with this summary? Do you agree with the summary I put in here?
Yes.
Yes.
And then how about the positive number? If the absolute value of a positive number is the same as the number, yeah?
Yes.
We didn't do this before, did we?
No.
No, we didn't. Okay. Sometimes I'm a little, I wasn't sure. Okay. So now on the negative number, we have two examples. We have two examples, right? These two examples. And what have we observed? The absolute value of a negative number is what? What pattern did we find?
That it turned out to be positive.
Yes, they're going to be positive. But how is it related to the given input? Okay. The output certainly is always a positive or 0. But how is the output related to the input? Are they related somehow?
They have the same number.
They're the same number. They're the same number. If it's negative, the absolute value of -3 is 3. The absolute value of -7 is 7. the absolute value of a negative number is 3 opposite of -3? Is 7 opposite of -7? They're on the either sides of the number line, right? So could I say the absolute value of a negative number is its opposite? Could I say that? Do you agree?
Yes, I
All right, wonderful. Now, I want to make sure everybody agree with these 3 statements, okay? So we observe numbers and we classify and we find pattern. And we find patterns and we verbalize the pattern. Do you follow me? We verbalize the pattern until we are certain the statement we make is correct or is true. Do you agree with these 3 statements in the summary? Do you?
yes.
Okay. But if you look at the first one, the absolute value of a positive number is the same as a number, and the absolute value of 0 is the same as 0. These 2 sentences actually can be combined. Do you think so? You think I could combine these 2?
Yeah.
How do I combine these 2? I can combine these 2 into what? Into what? Into one sentence, could I? Combine it into one sentence. That one sentence is the absolute value of a non-negative number. Do you guys know what's non-negative number? Non-negative number including positive number or 0. Okay, so when you put all the positive number and 0 together, they will no longer be called positive. They're called non-negative numbers. It's a class of number that include the 0 and positive number. Do you follow me? We've seen this word being used before, right? For the square root of x, and the domain is x is non-negative number, right? Do you guys follow me?
Yes.
So the absolute value of a non-negative number, so I combine the positive number and 0 together, which is the first half of the sentence before is the same as a number, is the same as 0, is the same as a number. So I would say is the same as the number. Do you agree with that sentence? Hmm? Do you agree with that sentence? Oh, sorry. Why did I put it here? You guys follow me? So right now we're thinking about the examples. We're going to summarize it. I want to find patterns, and we verbalize the patterns. Yes. So one sentence is the result of 2 sentences. So we just condensed it. Do you follow me? And the second sentence, okay, well, after condensing, we have another sentence, which is right here. Okay, the absolute value of a negative number is its opposite. Do we still agree with these 2 sentences?
Yes.
Very good. Okay, so we're going to put these 2 together. Okay, and we put it right here. Now, how will these be translated into mathematical expression. Let's look at the first one. Okay, let's look at the first one. The absolute value. Okay, how do we express the absolute value of a non-negative number? How do we express the absolute value of a non-negative number? Okay, so I'm going to put it right here. Okay, how do you express the absolute value of a non-negative number? Right, we know absolute value is just these signs, right? Shorthand notation. Shorthand notation. That's the absolute value of a non-negative number. How do you say you can put a number here? We often use X to represent it. Well, we can use any symbol to represent it. So that's today, that's not using X. We use omega just for change, right? But this number in here has to be non-negative. So how do we tell the reader that this number is non-negative? Well, we're going to say, okay, this number has to be greater than or equal to 0. Right? You follow me?
Yes.
Okay, so now then I'm going to switch place so that I can make the is, right? Because after all, it's about absolute value of this quantity, right? Omega is translated into equal sign. The same as the number. Which number? Omega. Translation into mathematical notation. Do you follow me?
Yes.
Okay, so I'm going to move this away and I'm going to put if, because after all, this is about non-negative numbers. So I need to tell the reader if omega is greater than or equal to 0, then the absolute value of this non-negative number is the same as number. Do you agree with this notation? Does this notation make sense to you? This notation basically is a shorthand notation of this long sentence. Would you please write it down? Could you please write it down? And next, we're going to work on translating this other sentence. You follow me? Yes?
Yes.
You ready? This is the sentence, and this is the shorthand notation. The shorthand notation says, if the number we're taking absolute value of is non-negative, then the absolute value of this non-negative number is the same as the number, which illustrate that, okay, okay, so I'm going to put it here, okay, just to enhance understanding. If the input is positive or 0, the input is greater than equal to 0, okay, you can use any symbol, we're using omega, so we're going to consistently using omega. And the output is going to be, this output is going to be the same as the input. That's what we're saying. Okay, 3 categories. Now, how about this second sentence? The second sentence, once again, we're dealing with absolute value of, right? Absolute value of this phrase is replaced by this shorthand notation of a negative number. So we're going to have a number inside the absolute value, but it's a negative number. How do we tell the reader omega is a negative number? Now we tell the reader omega is negative, less than 0. Okay, so we kind of switch place. We put it here. Okay, and we use a little bit if statement, say if omega is negative, right? Then the absolute value of omega is it's the opposite. The it refer to the input it. Okay, so I'm going to have this input is it, right? The input is it and its opposite. What is it? How do you express the opposite of omega? You just put a negative sign in front of it. That's how we express opposite of omega. Omega itself is negative. The absolute value of omega is the opposite of omega itself. I know it's a little bit difficult to understand this, and last time we had some questions, but I hope you guys will get it this time, but please feel free to ask questions. Okay, so this time we have omega still as input, and we give it to the out, give it to the function absolute value, right? And the output, of course, the output is absolute value of omega, right? That's the rule. Okay, we follow that same rule. But because this omega is negative, smaller than 0, because it's smaller than 0, therefore the output is positive, of course, but in relation to the input, it's the opposite of that input. Does everybody follow me? Does everybody follow me?
Yes.
Okay, so let's experiment with it. Okay, let's practice with using these words. Okay, let's practice using these words. Okay. Let's do a positive number example. That's easy, right? The absolute value of 125, because 125 is a positive, so the absolute value of a positive number is the same as the number. Okay. Now, let's look at absolute value of negative 10. Negative 10 is negative. The absolute value of a negative number is its opposite. We put a negative sign in front of negative 10. Voila, we get 10. You follow me? So now I want you guys to practice using this sentence. Okay, you guys ready? Practice using this sentence. Okay, the absolute value of negative 12, the absolute value of negative 36. I just pick up some random examples, but I want you to use the sentence. Okay, don't give me 12. give me the absolute value of a negative number is its opposite. It is negative 12. Its opposite is negative of negative 12. That's what we meant by its opposite. Its opposite. Do you follow me? Could you do that for me? Do that with your heart and mind. And now, do you still agree with me? Do you still agree with me? Yeah? It's the opposite of negative 36, which is positive 36. By doing so, we make a connection between output and input. That's how they're related. That's how they're related. Okay, so now we have these two sentences now. We have this sentence, right? And we also have this sentence. Okay. How does mathematics condense these two sentences? This is still not condensed enough, according to some mathematicians. Okay, according to most of mathematicians, because after all, this is going to have an even shorter notation about these. And that shorter notation is as follows. Okay, the absolute value, this part is a common. This part is a common. Okay, so we're going to write it only once. Equals to, there are two cases. There are two cases. And so these two cases will be marked by two cases. Okay. If this is the case, then the absolute value of omega is the same as omega. If the second case, and the absolute value of omega is going to be its opposite. This is the final version of the condensed form. You see, we came in a long journey how to get there, right? We observe the pattern and we classify, we verbalize, we summarize, and we can, combine these two cases. Negative number is the third case, and we have first case, second case into one. So we translate. So in the end, we finally get this form. And this form, which is the same as that one. Because we simply replaced omega by x. Does everybody follow me? You see the progression of mathematical notation? Shorter, shorter, shorter yet. So now how do we read this? How do we read it? Or how do we read this? Well, this is how we read it. Okay. It reads Okay, I'm gonna add one more column. Wait. No. Add one more column. Add one more column. Okay. Okay. It reads, okay, so we're going to put the sentence right here. The absolute value of a non-negative number is the same as the number. That's how you read it. Okay. And the second sentence, guess how we read it? The absolute value of a negative number is its opposite. Do you guys follow me? Condensed form. That's the condensed form. Of course, this is the same thing. The only difference is you use different symbols. So over here, we just copy and paste. Okay. You usually don't see this. You always see this in the mathematical textbook. And of course, you're going to see the shorter version of it. You're going to see this. Okay. And you're not going to see these. But in your mind, you know this. Do you follow me? In your mind, you know how to read it. So what I'm teaching you here, I want to tell you how difficult it is for a lot of our students. If it seems to be simple to you, that's great. Okay. But I believe that you're going to go back and forth. Is it right? Is it not right? So on, back and forth multiple times, because I'm still teaching my pre-calculus class students, okay, which is 3 classes after this, right? College algebra, trigonometry, pre-calculus. I'm teaching pre-calculus class, and some of them still have a hard time with this. Okay. And some people who are taking calculus class, they have a hard time with it. The sooner you get over this, the better off you will be. Is everybody with me? Hello?
Yes, Professor.
Are you there? Okay, good. So can we move forward? We're going to practice. Okay, next we're going to practice. Okay, so please look at Alpha 6. So please look at Alpha 6. Did you take all the notes? Did you take the notes? Did you take the notes?
Yes.
Mathematical notation, shorthand notation, and so on and so forth. Okay, if you don't understand the shorthand notation, it's very difficult to understand anything. Okay, because mathematics is a highly shorthanded notation. It's a highly shorthanded notation. You have to understand the notation. Okay, I know that for sure because when I was a student, studying, because I was a major in mathematics, right? I was majoring in mathematics. You know, I was learning all these different subjects of, different topics of mathematics, right? Every textbook, they have their notation. Okay, a lot of notation, of course, they're consistent. It's across the board and, internationally. But there's some, harder topics and their notation, you have to really understand that notation. A little notation, they mean a lot of things. If you don't understand that the notation, you cannot, you read 5 pages, you don't understand the notation, you don't understand anything. I'm not exaggerating. Okay. So you can see this notation, how it evolves into such a short notation to the point that a lot of people don't understand it. But if you translate it, if you know where it came from, there you go, you're good. Okay, so let's see, let's work on Alpha 6. Alpha 6 is prepared for you to understand this notation. Okay, so I know that you for a lot of these questions, you can do it very easily, but I'm asking you without, you do it without a calculator. Do you guys see Alpha 6 exercises there? Did you see it? Did you guys see it?
Yes.
Okay, I'm gonna skip some exercise and we're gonna go straight to number 7. Number 7, how would you do it? Without a calculator. Without a calculator. How do you do it? This is how you do it. Okay, I'm going to give you an example. Pi is a number larger than 3, smaller than 4. Yeah. Okay, so I'm going to give you some think out aloud. Okay, I hardly care what pi is. Okay, I just know pi is less than what? Pi is less than what? Pi is less than 5. Pi is less than 4, therefore it's less than 5, right? We're doing pi minus 5, therefore pi minus 5 is negative. So pi minus 5 is negative. Is negative. Right? Negative means it's less than 0. Pi minus less than 5 is less than 0. So the absolute value of pi minus 5 is what? Is going to be what? It's the absolute value of a negative number, right? The absolute value of a negative number is it's the opposite. So if this number is negative, right? That's the omega x or something, right? And then is its opposite. The opposite of pi minus 5. Do you follow me? Do you follow me?
Yes.
And then once we get rid of the absolute value sign, we can distribute the negative sign inside. So we're going to get a 5 minus pi. Do you follow me? Okay, so this part is thinking out loud part. You don't have to show. You don't have to show me. So let's continue. Let's finish up the work. Okay, the work, the part of work you're going to, excuse me, you're going to show is this. You recognize pi minus 5 is negative. The absolute value of a negative number, it's opposite. And then you plus 3. As soon as you get rid of the absolute value sign, you can operate the way we're used to. Okay, you're going to have 5 minus pi, then plus 3. And now finally, you're going to get 8 minus pi. This is the kind of work we want to see from you, which is applying this, especially the absolute value of a negative number is its opposite. Does that make sense to you? Does that make sense to you guys? So if you understand number 7, would you like to try number 8? How about you guys do number 7 first? Okay, I'm going to put this away. You're going to get a fresh piece of paper. Okay, don't look at your notes, to look at number 7 to see if you can repeat what we did without looking at the notes. It's a self-checking, okay? I'm not coming to watch you, okay? And I'm not going to send my goblins to watch you. You're completely safe and secure. You have your privacy. But I want you to practice doing number 7, applying the sentences we have just learned and summarized to see if you can do it. It's a little bit of abstract thinking, isn't it? Is that a little bit abstract thinking? Absolutely. Without using calculator. Without using calculator. Without using calculator. Without using calculator. Number 7, did you reproduce it? Did you do it all by yourself? Okay, if you can do number 7 all by yourself, okay? Now let's look at number 8. Can you do number 8? You can see how we do it, right? You assess what is inside the absolute value. Is it positive or is it negative? If it's a positive, the absolute value of that number is going to be the same as the number. If it's a 0, the absolute value of 0, of course, is 0. If it's a negative, the absolute value of the negative number is going to be its opposite. So all we have to do is assess, is this quantity positive or negative? Is root 3 minus 2 positive or negative? No calculator, okay? No calculator, please. How do you decide whether root 3 is a positive or negative? How do we decide root 3 is positive or negative? If you don't use a calculator. Well, one of the ways to decide okay, we know that 3 is less than 4, isn't it? Right? 3 is less than 4. How about we take a square root? You take square root on both sides. The square root of 3 is less than 3 square root of 4. And square root of 4 is what? Is 2. Therefore, root 3 is less than 2, yeah? If root 3 is less than 2, then root 3 minus 2 will be negative, isn't it? Agree? Right? Does everybody follow me?
Yes.
If root 3 less than minus 2, if root 3 minus 2 is negative, the absolute value of a negative number is what? Is its opposite. So this is the it. You follow me? That's the it. If root 3 is less than 2, 2 is larger than root 3. Therefore, 2 minus root 3 is positive, right? So 2 minus root 3 is positive. The absolute value of positive number is the same number, right? So on the second part, the absolute value of 2 minus root 3 is going to be the same as the number. Do you follow me? So that's how we get rid of the absolute value sign. You follow me? Do you follow me?
Yes.
All right, so now once the absolute value sign is gone, we can distribute the negative sign now. Okay, so we have 2 minus root 3, right? And over here we have a plus. And then finally we get 4 minus 2 times root 3. Because we have 2 of them, minus root 3, minus root 3. 2 and 2 combined, that's the 4. And that's final. Can you do this? Can we do this? Right? Look at that. We have a root 3, negative root 3, negative 2, 2. I'm just going to cross them out. We get 0. How about that? Can you do that? And obviously, you know we can't, right? Okay. Does everybody follow me? Does everybody follow me? If you think you understand, okay, I'm going to give you a couple more exercises to do in class. Okay, so please try these. Okay, apply the sentences we learn. Okay, apply the sentences we learn. Number 11, number 12. Number 13, number 14, number 15, number 16. Okay, that's quite a lot of exercise, but I think it's worth it that we do this in class. Okay, do you guys have the questions in front of you? Absolute value of pi minus 1 plus 2, and this is 12. The absolute value of pi minus 6 minus 3. The absolute value of 2 pi minus 6 minus pi. 14. Absolute value of root 3 minus 4 plus absolute value 4 minus 2 times radical 3. Okay, all these are enhancing our algebraic skill. Okay, all of these to enhance our algebraic skill. So root 2 minus 1 plus 3 minus root 2. Two times root 3 minus 3 minus root 3 minus 4. Okay, try to use these sentences to resolve the question, to simplify. Okay, because this is to enhance our algebraic skill. Skill. We found the pattern, we use the pattern to come back to solve our question, our questions at hand. With that, we're going to take a break for 10 minutes. Okay, you can continue to work on it, you can think about it, and we'll come back. How about that? So we'll be back at 11:40 a.m. Okay. Did you guys finish these? Shall we compare notes? Right, we apply these two sentences. Okay, these two sentences are so important, right? We need to practice them, practice using them. Okay. The absolute value of pi minus 1. Pi is larger than 3, right? So pi minus 1 is positive. The absolute value of positive number is the same as the number. So it's going to be the same as pi minus 1 plus 2. So in the end, the answer would be pi plus 1. Okay, pi plus 1. How about pi minus, how about number 12? Do you guys follow me? Hello, is everybody there?
Oh, I'm here.
Yeah.
Okay. What is the absolute value of pi minus 6? Well, pi is less than 4. If it's less than 4, it's less than 6. So pi minus 6 is negative. The absolute value of a negative number is what? Is its opposite. And then minus 3 equals to, and then you can operate, you do, 6 minus pi minus 3, right? And in the end, you can combine the 6 and negative 3. You're going to get 3 minus pi, right? You get 3 minus pi without having to use a calculator. Okay. So next, 2 pi minus 6. So you just have to decide what's inside the absolute value sign, whether it's positive or negative. If it's positive, the absolute value of that positive number is the same.
I have
If
a
it's
question.
0, it's going to be 0. If it's negative, it's going to be its opposite. Does that make sense? So you just have to decide the sign of the number inside the absolute value. 2 pi minus 6. Pi is larger than 3. So 2 pi is larger than 6. So 2 pi minus 6 is a positive. The absolute value positive number is the same as the number. And then you do then minus pi tag along. And so in the end, you're going to get a pi minus 6. Do you follow me? Does everybody follow me? Yeah? Do you think you got the hang of it?
For 12, is it cool if I got a pi minus 3 instead of 3 minus pi?
How did you get pi minus 3?
I just switch, I just put the pi in the front instead of putting the 3.
Can you show your work? Can
Yeah.
you send your work to us?
Well, give me a sec.
Okay, no problem. Well, if anyone want to share the screen, I can give you the screen to share. I'll give you the screen to share. All right, everybody. So let's look at this piece of work. Did you guys see it? Okay, so did you guys see this? So I'm gonna critique it. Pi minus 6 is negative, so therefore absolute value pi minus 6 is the opposite. That's this step is right. Minus 3 is good. And then you get 6 minus pi, distribute the negative sign, that's good, minus 3. And then you get a pi minus 3. That's not correct because you see 6, positive 6 and negative 3 will combine. That's a 6 minus 3. 6 minus 3 is a positive 3. So this is going to be a positive. This is going to be plus 3. There's a negative sign in front of pi, so this needs to be a negative sign. You follow me?
Yes, Professor. Thank you.
Okay, so the answer should be either negative pi plus 3 or 3 minus pi. Anybody else have any questions? Okay, so I'm going to put this away. Okay, let's go back to here. Number 14. What did you do for number 14? Anybody want to share? I can share a screen with you. I can allow the sharing screen. Anybody want to share? Allow share screen. Anybody want to share your screen, or you take a picture, or you want to take a picture? That will be fine too. Number 14. What did you get? root 3 obviously is less than 4, right? Root 3 less than 2. 2 is less than 4, therefore root 3 is less than 4, right? So if root 3 is less than 4, the first absolute value is the absolute value of a negative number. So this quantity is a negative number. The absolute value of a negative number is its opposite. Now the question is, which one is larger? 4 is larger, or 2 times root 3 is larger? Without using calculator, try to use our brain. Well, root 3 is less than 2, right? So 2 times root 3 is going to be less than 4. Therefore, 4 minus 2 times root 3 is going to be a positive number. So this quantity is a positive. The absolute value of positive number is the same as the number. See, boom. And then we can operate. Okay, so I'm going to have 4 minus root 3. Okay, and plus, and of course, plus the rest of it. Now 4 and 4 combine, that makes 8. Negative root 3 minus 2 root 3, that make it minus 3 root 3. Done. Any question? Okay, 2 more to go. 2 more to go. Did you guys finish these 2 already? 15 and 16? Did you finish 16? Did you finish 15? So by this time, I think you got the hang of it, right? Well, root 2 is larger than 1, so root 2 minus 1 is a positive. The absolute value positive is the same as the number. And root 3, 3 is larger than root 2. Okay, 3 is larger than root 2 for sure. Therefore, these 2 numbers are both positive. This is positive, right? So the absolute value of positive number. So when you work your steps, you know what you're doing. 3 minus root 2 is positive. The absolute value of positive number is the same as the number. Boom. And then you just combine the numbers. Negative 1 and positive 3, that makes positive 2. And root 2 and negative root 2, that makes 0. Therefore, the final answer is just 2. Okay. Last but not least, you see, we repetitively using these 2 sentences. The absolute value of a non-negative number is the same as a number. The absolute value of a negative number is its opposite. Yes? All right. So now, number 16. 2 times radical 3. Is it larger than 3 or is it smaller than 3? That's the question, right? But root 3, what is it? 2 times root 3. How do we figure this out without a calculator? How do we figure this out without a calculator? How do we figure this out? How do you figure this out? Without a calculator, without a calculator. Hello, are you guys there? How do you figure this out? I will tell you. Okay, I'm going to tell you how I figure this out. Okay. Think out loud. Think out loud. Which one is larger? Which one is larger? It's hard to compare, isn't it? So what I'm going to do is I'm going to square this number. I'm going to put this in a square. Okay, what does that equal to? That's going to be 2 squared multiply root 3 squared. That's going to be 4 times 3. That's 4 times 3. That's 12. I square this number, I'm going to have to square 3. What happened? What is 3 squared? It's 9. Obviously, 12 is larger than 9, isn't it? Do we agree? Do you agree with me? Right? If 12 is larger than greater than 9, I'm going to take a square root on both sides. And it's still going to be the 12, root 12 is going to be larger than root 9, right? Root 9 is 3. And this one is what? If you simplify, okay, this is what I would do on scratch paper, okay? So that's going to be 4 times 3. Right? When you take the root 4 is 2, so 2 times root 3 is larger than 3. So that's how we can figure this out. Okay, so 2 times root 3 is larger than 3. So this number is larger than that number. So this is a positive number. The absolute value positive number is the same as the number. Minus. Root 3 obviously is less than 4. So root 3 minus 4 is going to be a negative number. And the absolute value of a negative number is its opposite. Okay, so this I'm going to over here, I'm going to put in some layers of, because I don't want to be making a mistake. Okay, so this bracket, it corresponds to this absolute value. The absolute value of a negative number is its, okay, its opposite. Do you guys follow me? These two correspond to each other. In front of them, there's a negative sign. We don't want to be interrupted by that negative sign in any wrong way. This parentheses is absolute value. This absolute value is absolute value of negative number. So the absolute value of negative number is its opposite. Okay, so next step, we're going to open up. Well, there's a negative sign here. There's a negative sign here. So coming out of this piece is going to be plus root 3 minus 4. Does everybody follow me? Does everybody follow me? Now we can combine. Okay, 2 times root 3, 1 times root 3, and they're plus. And the final answer is going to be 3 times root 3. Okay, 3 times root 3. -7, -3, -4, that makes -7, -7. That's final. That's final. So you can see besides learning these 2 major sentences about absolute value, okay, these 2 sentences will help us to get rid of the absolute value sign. How can we get rid of the absolute value sign? Well, if it's a positive, it came out the same. The 0 came out the same. Negative came out opposite. Came out opposite. Okay, so without further ado, that was absolute value. That was absolute value. You think you got the hang of it? Okay, because the operation involve absolute value. It's very, very limited. There's very limited we can do. Okay, we cannot arbitrarily just open up. So we have to do it by checking the sign inside the absolute value. So without further ado, today we are going to move on to alpha 7. Alpha 7. Okay, what is alpha 7? Okay, alpha 7. We mentioned there are 2 kinds of sentences in mathematics. 1, 2. 2 kinds. Only 2 kinds. 1, 2. Right? 2. A lot of the things we learned so far, right? Alpha 4, alpha 3, all these functions, excuse me, they're just statement. Okay, there's just statement. Okay, so in mathematics, we have statement. And the other kind we talk about is called if statement. Alpha 7 is if statements. Okay, the title itself is already shorthand notation. The title itself is already shorthand notation. So let's look at alpha 7. Okay, this is an if statement. What is the title for it? The title says solve for this title itself is already indicating it is an if statement. Okay, so are you guys with me? You guys still with me? I know it's noontime. You might be hungry. Okay. I just had breakfast before the class. I just had, breakfast before the class, so I'm not terribly hungry. Okay. Now, when you see solve for x in mathematics, you've probably seen this a lot. Have you seen this a lot? It actually tells you it's an if statement. It's if statement. Okay, so solve for x is an if statement. What kind of if statement? Okay. How to read the if statement. For example, in alpha 7, right, you have a common title, which is solve for x, right? And then you start to have questions. The first question is absolute value of x is equal to 3. And they ask you to solve for x. Okay. Okay, guys. No hurry to find the answer. Okay. To me, from my teaching experience, I believe that if you understand the meaning, the answer is right there. You don't need to struggle too much to get the answer. Most of our students, I hope it's not you, but I suspect it might be you. You don't understand what it means. Okay, you don't understand what it means. That's why it causes you lose points left and right. Okay, so I'm going to spend a lot of time to explain to you what it means. So under this context, solve for x over here. Okay, I'm going to tell you the meaning. The meaning. Okay, the meaning is if the absolute value of this number we don't know, okay, the absolute value is 3. What are the possible values for x to make the statement true? That's one meaning. Okay, there's another interpretation. Okay, I'll tell you this a little bit later. Do you guys follow me? Do you guys follow me? That's the meaning. So for every question, 1, 2, 3, 4, 5, 6, 7, 8, 9, the alpha 7, they all mean the same thing. It's just different numbers. Different numbers. Do you follow me?
Yes.
So every time you see solve for, it's a big if statement. It's if. Right? And then find all possible values. Remember, there are only 2 kinds of sentences in mathematics. So all of these solve for, you're going to see today, this semester, next semester, or someday you're studying to get a math PhD, math doctorate. You're also going to have similar wording. They all mean the same thing. Do you follow me? It's the same sentence structure. Okay. If you find something that's different from what I said, right? Statement, if statement, you have more than that, please, you come back to teach me. You come back to teach me, I would appreciate it. I would like to learn something new. So far, I haven't seen anything new, anything more than that. Meaning. That's meaning. So now, understand that meaning. Do you know the answer? Think of the meaning. What will be your answer? If the absolute value of a number you don't know, x, right, is 3, what could x be? What could x be? You tell me. Forget about mathematical notation, right? You just understand the absolute value notation, right? You can even put more words to it, right? If the absolute value of x, right? You can even say, let's not using any notation. Say, if the absolute value of x is 3, what are possible values for x, right?
3 and -3.
That's right. You see, you understand the question, the answer is right there. No need, there's no need to memorize anything. Your answer is perfect because -3 will make it true. If you plug in -3, it will make it true. If you plug in +3, it's also going to make it true. So do you agree with me? It's paramount for us to understand the meaning, isn't it? It's more like someone is asking you a question. You don't know you don't understand his question, then you give an answer. How big a chance that you're going to hit his question? Right? You have to understand the question first, right? So once you understand the question, the answer is obvious. So now let's look at the shorthand notation. Let's look at the shorthand notation, okay? So the meaning is important, but the meaning is consistent in one frame of sentences, which is the if statement. Okay, that's what I meant, if statement. If that's true, give me all the solution. If this is true, give me all the solution. Okay, so now, if this is true, the solution would be -3 or +3. And the other way to express it is using shorthand notation, right? So x is equals to +3 or -3. So all of these notations, the way we write it, they have specific meaning. They do. Okay, for example, this will mean if x is -3, it's going to be a true statement. If it's a +3, it's going to be a true statement. So you're merely telling the reader, say, and the whole thing means what? The absolute value of, if you write in words, right? If you write in words, you say, well, you say if the absolute value of x is 3, right? Then you say then x maybe -3 or +3. You don't know which one, but you know it's maybe -3 or +3. You don't know which one. It's either this one or that one, because x can only assume one value at a time. It cannot assume two different values at the same time. Okay, it's or. It's or. Do you follow me? So this is the one meaning. Second meaning. Second meaning. The second meaning lying in the function. Okay, you see on the title, I said the meaning in function perspective. Okay, so meaning in function perspective. Meaning in function perspective. Okay, a function, well, absolute value certainly is a function, right? It takes the input, x, it produces output. Produces output, input, output. Okay, so let me draw that. The input is x, the output is 3. That's what it tells you. This basically tell you, okay, this tells you if we don't know the input, but we know the output is 3. Okay, we know the output is 3. How do I know it's output 3? Because it's written that way. This tells you the output is 3. If the output is 3, what are the possible inputs? Guys, could you tell me? If the output is 3, what are the possible inputs?
-3 and +3.
That's right. That's right. That's the meaning. Okay, so I'm going to call this meaning number 1. They all agree with each other. Okay. Number 2. Actually, I have a number 3. I have a meaning number 3 to share with you. Graph. Meaning number 3. The graph. Okay. Input, output. The graph is about input output, isn't it? The graph is about input output. Okay, so let me just make a little bit adjustment for the graph. Okay, we're solving for x. We're solving for x. X obviously is the input. And we know the output, right? The output is about how high it is, right? Okay. We know the output is 3, right? The output is 3. So how do we express output is 3? Output is 3. Okay, so let me just make it a little bit longer. Output is 3. What is 3? Output is 3. Okay, the output is 3. Oh, sorry, that's hard to see. Okay, the output is 3. Okay, the output is 3. Output is a vertical concept, right? Output is a vertical concept. So this is output is 3. On the curve, output is 3. Okay, we don't need that one anymore, but it means 3 anyway. So on it asks us, if this is the rule and we know the output is 3, can you give me the inputs? So what are the inputs that will make the output is 3? What is it? Tell me. What input will produce the output 3 under this rule?
-3 and +3.
That's right. That's right. Do you see all 3 meanings is related to the if statement, isn't it? And they are consistent, they explain to each other, and they're consistent with each other. Do you follow me? Okay. So next, I want you guys to reflect on these meanings, all 3 meanings. Okay. And I want you guys to try number 2. And reflect on all 3 meanings. And of course, give the answer. See, understanding mathematical notation and its meaning is very important, right? If you understand it, the answer is right there. Very easy to get the answer. But if you don't understand it, you forever struggle. You feel you have to memorize. No, no need to memorize. No need to memorize. You just have to understand the meaning. Try number 2. Absolute value of x. Solve for, of course, equals to √5. Square root of 5. All right, solve for x. All right, solve for x. So you reflected on the 3 meanings, right? Reflect on the 3 meanings. So if we think about these 3 meanings, right? The first meaning, if the absolute value of x is √5, right? All you do is you copy the entire sentence, right? Meaning number 1. Meaning number 2. The function perspective, right? The function perspective, what input will cause the output to be 3, meaning in function perspective. Oh, wait, where did I go? Sorry. Here. And third one is a graph. 2, 3. Graph. Right? The only difference is 3 now is root 5. Just the number is different. Right? So if you look at the graph, instead of having a horizontal line there, we're just having horizontal line root 5. Boom. And of course, you just have to figure out what's the input, right? And the input would be positive root 5 or negative root 5. So the answer would be x equals to positive or negative root 5. When you reflect on those meanings, the answer is obvious, isn't it? The answer is obvious. Okay, so I'm going to jump a couple questions. I want you guys to think of number 6 and number 7. Okay, let's work on number 6 and 7. Think of meaning. Think of meaning. And this meaning, okay, solving for, this is absolute value of x equals to negative 3. And this is absolute value of x equals to 0. Solve for x. Solve for x. Solve for x. Okay. I'm going to give you a couple minutes. Okay, reflect on the 3 meanings. Reflect on the 3 meanings. Okay, what have you discovered? What have we discovered? What is the solution for number 6? What is the solution for number 7? All right, ready? Number 6. Number 6. What is the answer? If the absolute value of a number is -3, what could x be? What could the number be? If the absolute value of x is -3, what could x be? What input will produce the output of a -3 under the same rule, of absolute value? Function perspective, right? Words, graph. Hello, everybody. Nobody answered. Nobody says anything. Are you guys still there? Are you there? Let me call up some names. Alan, are you there?
Yeah.
Brianna,
Yeah, I'm here.
Devin, Francesco, Madison, Marcelo, Randall,
I'm here.
Safatra.
I'm here.
Good. All right. So what's your answer? What's the answer to number 6? We want the output to be -3. What the input will make that happen? We want the output to be 0. What input will make it happen? We have studied this function, right? We have studied this function, isn't it? And we studied its domain, we studied its range. Right? We studied its domain, and we studied its range. Thank you for your responses on chat. So what's the solution? What are the possible inputs such that the output is -3? The domain for this function is what? All real numbers. And the range? What is the range? The range is greater than or equals to 0. So now we want the output to be -3. If you graph -3, what you get? You draw that horizontal line. It doesn't even touch the curve. What does that mean? There's no input to produce that output. No solution. Do you follow me? The curve is here. This is a -3. This is the output of -3. It will never produce this output. There's no input to produce that output. Besides, this output is not even in the range. Therefore, what's the answer? No solution. How about number 7? How about number 7?
0.
0.
That's right. There's only one solution. Okay. You can see other examples we have done. The first example, second example, right? There are 2 solutions there. Here, there's only one solution. And number 6, there's no solution. Okay. So the solution is what? X equals 0. Very good. Okay. And if you graphed it, okay, if you graphed it, right, you're going to graph that 0 the 0 touch the curve once. So for that input, the output is 0. It touched it only once. And in other situation, how many times touch it? Touch it twice. You see, in the root 5, it touched twice. At 3, it touched twice. You follow me? Touch twice, 2 solutions. Touch twice, 2 solutions. No touch, no solution. One touch, one solution. Got it? Yes?
Yes.
So 3 meanings, 3 interpretations, they're all consistent. It's just a different perspective. Just different perspective. Next, I want to take you guys to alpha 8. Okay, alpha 8. Okay, alpha 8, once again, is the same solving title, solve for x, the same title. So it's a big if statement again. It's an if statement again. Okay, so we're also going to have 3 interpretations. We're going to have 3 interpretations. But this time, all these functions we have here really is the square root of x, root x, root x. Okay, let's take the first example. And we're going to focus on the meaning first. The root x is equals to 3. So what will be the meaning? Almost the same sentence. Instead of the absolute value of x, it is the root of x. If root x is 3. You guys see me? The difference is just the rules are different. Do you follow me? If it's not an absolute value of x, it's the root of root x. You take a square root of a number is 3. And what are the possible values for x to make the statement true? The second meaning is still the function, input. Okay, the second meaning. And we want the output to be what? To be 3. And what are the input? And third one, the graph, function graph. What is a graph? With a graph, it comes with definition, right? What is the graph of root x? Didn't we just do that? What is the graph of root x? Remember the points we plotted? Remember the domain, the range? Yes? Does everybody follow me?
Yes.
Do you still remember the points we plotted? Right? Could you, do you want to go back to look at your notes? I'm going to go back a little bit to see the work we did. Right? The root of x. Where did we do it? We've done so much work. Ha. Did you find the notes of that part? We surely have done that, right? Oh, right here. The picture we did, right? The point we plotted. The domain we thought of, the range we thought of, right? The domain we thought of, the domain we worked out, the range we worked out. So now they ask us, if the output is 3, what will be the input? If the output is 3, what will be the input? Huh? Wouldn't you be drawing the same line? Right? That's the output, right? What input corresponds to that output? How many do we have? How many times it crosses?
Once.
So what's the answer?
It's 9.
That's right. That's right. Okay, so the answer is what? The answer is how many? 1, x equals 9. Okay, so the 3 perspective. So we start to realize the output has to be in the range, isn't it? When we did alpha 7, when the output was -3, and -3 is outside the range. When it's outside the range, there's no solution. Are you guys with me? When there's an if statement and the if statement tells you that the number is outside the range, in that case, there's no solution. Follow me? All right. But I do want to show you another trick. Well, I wouldn't call it a trick. It's a trick. It seems to be a trick. I wouldn't teach it unless I know some of you might have learned it somewhere. Okay. Solving this equation, you might have learned this from somewhere else. Learned this. Okay. Root 3 equals to root x is equals to 3. Okay. And you're going to square both sides. You're going to square both sides. Square both sides. And the left-hand side is x, and the right-hand side is 9. Anybody have learned it this way? Can you raise your hand? Anybody learned it this way? or you put a message on the chat. Did anybody learn it this way?
I have.
You have. Thank you for sharing that. Thank you for letting me know, okay? Doing this is usually okay, but it could lead you to ridiculous answers if you're not being careful, if you're not being aware of the domain and range, okay? So you can see when you have a square root of x, you have a 3. 3 is in the range of root x, right? Because we know the domain. What is the domain for this function? X is greater than or equal to 0. Okay? And what is the range? Root x is greater than or equal to 0. Okay? So 3 is very well in the range. Therefore, you can do this all right. But there will be scenarios you do the same thing, you're going to get a ridiculous answers. Okay? This method needs to be used with extreme caution. Example, number 8 in alpha 8. Number 8, right? You have a root of x equals to -2. Root x, -2. Follow me? If you just square both sides, you square both sides, what are we getting? What are we getting? We get x equals to 4. But when you check your answer, okay, you take it back to your equation. You get root 4 equals to -2. We know this is wrong. This is what we call a ridiculous answer. This is a ridiculous answer we're getting here. Are you guys with me? Are you guys with me? So you cannot allow yourself to get into autopilot. Oh, when I see root something, I just square both sides. No problem. I'll get the answer. Well, you get an answer 4, but 4 is not the answer. Why 4 is not the answer? Because you plug in, you certainly see you're going to get 2 equals to -2, right? You get 2 equals to -2. 2 equals -2 is wrong. How did you get this ridiculous answer? Is it because -2, okay, -2 is outside the range of square root of x, which is the range is what? What is the range? The range is greater than or equal to 0. Do you follow me? And what will be the answer to this equation? No solution. Okay, from the graph's perspective, right? You will not be drawing this red line. You're going to be drawing this red line. It was going to be is going to be -2. This -2, this output of -2 has no touch with the curve. In other words, you never find an input to produce that output. No touch. No touch means no solution. You follow me? So you got a number, but that number is gonna take you to get you something very ridiculous. Do you follow me? You can see the domain and range we have done is very, very important to understand. -2 is outside the range. If it's outside the range, you'll never be able to touch it. If you have a rule, right? That rule determines domain and range. If you have a number outside the range, you never be able to touch it. What does it mean? Graphically, your curve would have no touch to that output. Never touched it, no solution. This is the caution I want to show you. This is the caution I want to show you. This is a cautionary, measure I want to show you. Okay, so we did quite a bit of stuff here, and you should expect another quiz. We will do Alpha 9 on Monday. Okay, so today's homework will be what we did from today: Alpha 5, Alpha 6, 7, and 8. Alpha 5, 6, 7, 8. You follow me? Yes?
Yes.
That's today's homework. I will send you another quiz sometime later today. And today's homework will be Alpha 4, 5, 6, 7. Do you have any questions? Please feel free to ask me questions, okay? As you understand, you can ask me questions anytime, 24/7, okay? Alpha 7. Did we go up to, let me double check. 7, 8, sorry, 7, 8. Alpha 8. Okay, Alpha 4 through Alpha 8. Okay, make sure you do all of them all over again. Okay, my quiz will be checking on those little details. Okay, those little details. Okay, the absolute value of negative number is it's opposite, right? So I may not show the entire work. I may show like part of the work for you to decide whether it's right or wrong. Okay. If you have any questions, please don't hesitate. I would start Alpha 9, but I feel it's a little stretch. I think we have plenty today. And I will see you guys on Monday. Okay. So I will stay a few minutes longer for you to answer your questions. So go on with your questions. I see there's two chat questions. Okay. Oh, okay. Yeah, thank you. So please bring your questions to me.